Geotrig, we are going to talk about trig identities day 3 or the first day of the addition and subtraction formulas. These are the formulas, and these formulas, guys, again, go work both ways. So what I say by that is that if I have a sine of two angles added together, that would equal the sine of s times cosine t plus cosine t sine t. If you're subtracting angles inside of a sine, it's sine s cosine t minus cosine s sine t. So, sine, addition, subtraction. You don't have to memorize two different equations. Memorize one. It's the same thing. The only difference is that there's a plus or a minus sign between them. And the way I like to remember this is sine keeps the sign. If you're adding between the angles, you're adding between the functions. If you're subtracting between the angles, you're subtracting between the functions. So it's sine, cosine, cosine, sine. Sine, cosine, cosine, sine. There is this video of a guy jumping around, sine, sine, cosine, sine, cosine, sine, cosine, sine, or something like that. Sine, sine, sine. So, yes, there's a video about that. You guys can look that up in your own time on your YouTube allotted time for the day, which is probably about 3 hours of your day. But, for weird cat videos. But then, we also have some formulas for sine or cosine addition and subtraction. And again, look, they're the same formula overall. They have just a different sign between them. So for cosine addition, it's cosine s cosine t minus sine s sine t. Or it's for the subtraction of angles, it's cosine s cosine t plus sine s sine t. Now, the way, again, I will do this is I'll remember one of these, but know that when I'm working with cosine, I'm going to take the cosine. Now I say it that way because it's not the same sign. Remember, sine gets to keep the sign, cosine uses the cosine, and if I'm thinking of a cosine, I'm thinking the opposite sign. I'm just trying to think, guys, of ways to help you remember so you don't always have to look these up. Because I'll guarantee you guys, on those first 2 pages of our worksheet, those who remember that sine squared plus cosine squared equals 1 had a heck of a lot easier time than those who every time you did something going, okay, now what can it be? It's true. The more you guys know, the easier things will be. And that's actually just for life. At least for the most part. Tangent. Think of tangent. Tangent is made up of a fraction. Yes? Sine over cosine? Yeah. So therefore, the results when you add or subtract functions leads to a fraction. Tangent of s plus tangent of t minus tangent s tangent t. Notice they are the exact same thing for the subtraction. The signs just flip. So it becomes tangent s minus tangent t over 1 plus tangent s tangent t. Again, you only have to remember one. It's just that you realize that the top gets the sign, the bottom switches signs. So subtraction's on top, but then the bottom becomes an addition. Again, I'm not going to have you guys remember these for, completely 100%, but I will at least hope for the minimal amount to say, hey, when I see something that looks like this in a problem, it might ring a bell that it equals something else, that when I look it up, you're like, oh, I can just take the tangent of the 2 angles added together, or subtracted, or the cosine added together. That's the point. Okay? I'll give you guys time to copy that down. Now, the idea here is that I want to find the exact value. every one of us could take our calculator out, put cosine of 75 degrees, and it'll spit out a decimal answer. Yay, we got an answer. But that's an approximation. We should know that not every trig value comes out to be like a 1 or a 1/2 or a 0, right? They come out to square root of 3's over 2. They come out to other things. So therefore, we are going to figure out how to do this with exact numbers. Here's the problem. Look at your unit circle. Does it have 75 degrees on it?
No. 30, 60, 90.
It's only 30, 60, 90, and 45s. So therefore, I can't just look this up on my unit circle and say, hey, there it is. Instead, I need to think of, how can I break up 75 with angles I know?
15 and 60.
15 and 60. You don't know 15. You know 60, but not 15.
Yeah, just 30.
30 and 45. Okay. Would you guys agree cosine of 75 would be 30 cosine of 30 plus 45? And those are degrees. You guys okay with this? And now here's the thing, guys. You have a cosine of addition of angles. Going back to the next page, or the page before, we had a formula for that. Cosine, well, looking right now, what was the cosine general form? Cosine, cosine, sine, sine. So, this will become cosine 30, cosine 45, sine 30, sine 45. What's the sign in the middle? It happens to be the opposite sign, so it should be a minus. Then the question is, do you know the cosine of 30? Yeah. You should. We have the ability to look that up. And now it just becomes the game of simplifying like we have in the past. Take out your unit circle if you don't know these by heart. What's the cosine of 30? It's not 1/2. It's square root of 3 over 2. Cosine of 45. Cosine of 45. Square root of 2 over 2. Sine of 30. 1 over 2. Sine of 45. Square root of 2 over 2. And now multiply those two groups together. And then make sure you have a common denominator. Put them together. So, how do you multiply fractions? Okay, what's square root of 3 times square root of 2? Three times square root of 2 times square root of 3 is square root of 2 times 3, which is square root of 6. Over 4. Minus, what's 1 times square root of 2?
Square root of 2 over 4.
Square root of 2 over 4. Hey, do we have a common denominator? Yeah. So let's put them together.
Ooh.
I heard someone say square root of 4 over 4. Can that actually happen?
No.
Not this way. Guys, you can't put two square roots together unless they are the exact same square root, because you're adding or subtracting them. So this would have to actually stay exactly like this of square root of 6 minus square root of 2 all over 4. This is the exact solution to the cosine of 75. I split it up into two known quantities and took the cosine addition of it. Guess what if I told you that's not the only way to get to 75? Couldn't I have taken something on the lines of, what other angles?
Add up to 75?
Or subtract.
Oh.
105 minus 30 That's not good enough. Ooh, could I have done 135 minus 60?
Yeah.
Guess what it would have resulted with?
Same.
The same answer. Okay? So it doesn't matter which pair or group you use, you will come up with the same answer.
There's going to be some things that will have to subtract to get the answer. Or the,
Yes.
okay.
Like 15.
30.
No. If I wanted to get 15, then I would want to do 60 minus 45.
Nice.
Okay? So there's a couple different times you're going to have to add or subtract to get an answer. Number 2 is asking us to do the exact same thing, but it's in radians. And that's the part that complicates it. I'm hoping none of this stuff for this problem was necessarily hard. Shouldn't have been a factor. But we're not most comfortable people with pi's over 12s or radians. So this is what I propose, guys. And it's not switch it to degrees. Because if it starts in radians, you got to do this problem in radians and finish in radians. So, what I will say is, what are all the different types of angles in radians that you encounter? You would encounter things like pi over 6, pi over 3, pi over 4, pi over 2, and pi. Pretty much 60, a 30-degree angle, a 60-degree angle, a 45, a 90, and then pi is 180. Would you guys agree with all of those angles? Those are pretty much all the angles you know on a unit circle or multiples of that you could form all of the rest of those angles. Or not all of them, but a lot of them. So what we need to do is we need to make them all have a common denominator. Because I'm not in pi's over 3s or pi's over 6s or pi's. I'm in pi's over 12. And so I want to make all of these have a common denominator of 12. And to do that, I multiply the top and bottom by what the missing piece is. What's the missing piece for pi over 6? 2. So it's 2 and 2, which results in 2 pi over 12. Agree? Yep. Pi over 3 is, so you get 4 pi over 12. 4? So it's 3 pi over 12. 6 pi over 12. And pi itself would be 12 and 12, which would be a 12 pi over 12. Everybody got that? Can anybody see why I would want to do this? What makes it so much easier? I multiplied pi by 12 over 12, so I can get 12 pi over 12. Just in case I need to use all of pi to get to an angle. Just like I did for the reason I did pi over 6, pi over 3, pi over 4. I want to have everything have a common denominator so I can add them together if I need to, or subtract them. And the only way to subtract fractions is if having a common denominator. So if I get the common denominator, I know my answer will have a 12 on the bottom automatically. So the question is, using some combination of those, can I take 2 of them and add them to get pi or subtract to get pi? Which ones and which way? 4 pi over 12 and 3 pi over 12. So couldn't I say that this is cosine of 4 pi over 12 minus 3 pi over 12? Would that result in a pi over 12? Yes. But here's the thing. I start off by getting the common denominator, so therefore I can look at how I can rewrite cosine of pi over 12. And I found out that a 4 pi over 12 minus a 3 pi over 12 would result in a pi over 12. I am now going to go back and reduce those. So when I go to reduce these, I end up with cosine of pi over 3, sorry. You're right. Pi over 3 minus pi over 4. And I did this because I know what pi over 3 is, and I know what pi over 4 is. I now use the formula for cosine subtraction, which is cosine, cosine, sine, sine, with what between? The opposite sign, so it's plus. So this would equal cosine pi over 3 cosine pi over 4 plus pi over 3 sine pi over 4. I moved some things around here so I got more room to work here. We're at the cosine pi over 3, cosine pi over 4, sine pi over 3, sine pi over 4. And I'm going to do exactly what I did in the last problem. And I'm going to exchange it for its ratio or its value. The exact value. What's the cosine of pi over 3? 1/2. What's the cosine of pi over 4? Square root of 2 over 2. What's the sine of pi over 3? Square root of 3 over 2. And sine of pi over, sorry. Yep. And, sorry. Yep. Wow. Woo, that's a lot of sorries. And sine of pi over 4 is? I was thinking, I thought we put square root of 2 over 2 on that first one there, which was square root of 3. Multiply these together. Square root of 2 over 4 plus 6 over 4, which would result in the Here's the thing, guys. I'm going to tell you, there's going to be a lot of square root of 2s and square root of 6s and square root of 3s over 4s because all the angles on our unit circle pretty much, that's the only numbers we have. So it's going to, and if you notice, they cycle around each other. So sometimes they're positive and sometimes they're negative. It's going to repeat itself, or seem to repeat itself quite often. And if you think about it, the sine of 30 is the same thing as the cosine of 60. They're both half. So you only have so many options. Homework today is worksheet number 3. I just want 1 through 3.